Welcome back. Now that you understand how the multimeter in your kit functions, let's dive into learning how to use it to measure values in your projects. In this video, I'll show you how to use a multimeter to measure voltage, resistance, and current. Measuring voltage can be very useful when building projects. You may want to do things like measure the voltage level of a battery or determine if proper voltage is getting to a sensor on your robot. With a multimeter, you can measure the exact voltage that is present at any point in your project. Just like you've seen in previous circuits that you've built, ground is the 0-volt reference that everything else is measured against. Another name for ground is common, and this can be found on one of the lead jacks on your multimeter named COM for common. The black lead plugs into this jack, and this lead will be connected to a ground point in your circuit to ensure that your voltage measurements are accurate. To measure voltage, ensure that your black lead is connected to the COM jack and your red lead is connected to the VWMA jack. Next, select the appropriate range from the voltage measurement options. The 20-volt range will likely be the best range to use for most of your Raspberry Pi projects, given that most voltages are around 3.3 or 5 volts. With your circuit powered up and running, carefully touch the black lead to a ground point and the red lead to the point at which you'd like to know the voltage. The display will show the voltage currently being measured between the black and red leads. If the display shows a 1 or a very small number, then you likely have the wrong range selected. So change the range to a better value for your expected voltage and try again. Measuring resistance will come in handy when checking to see if two components are connected or if you can't remember the resistor color codes. For this task, you'll use the ohms range on your multimeter. The main thing to remember about measuring resistance is that the component cannot be powered on. The multimeter will run a tiny amount of current through the component to measure its resistance, and this measurement will be thrown off if there is additional current flowing through the component on the circuit. So your multimeter can also be damaged if there is enough current coming from the circuit. So always make sure if you're going to measure your components that everything is disconnected from the circuit or the entire circuit is powered off before making resistance measurements. A term you might see related to resistance is called continuity. When something has very low resistance between 2 points, it's said to have continuity. This might apply to a single jumper wire or multiple connections made through wires on your breadboard. In the image you see here, a multimeter is being used to measure the resistance between 2 points on the breadboard that are connected by multiple jumper wires. With only 5.1 ohm of resistance present, these 2 points would be considered to have continuity. Now, you may see references later in this course to checking the continuity of a component or connection, and this just means using your multimeter to verify there is very low resistance between the points to be checked, which means you have verified there is a good electrical connection between these points. If higher than expected resistance or a complete open is measured, then you have located a problem that will need to be resolved before you continue. This may come in the form of a bad jumper wire, but if you're instructed to check the jumper wire for continuity, then the resistance of that wire should be measured. And if the resistance in that jumper wire is very low, say less than 10 ohms, then the jumper wire should be considered good and additional troubleshooting would be required to find the problem. Now, if higher resistance is measured in that jumper wire, then the wire or the connections have failed and the jumper wire should be discarded as you can no longer rely on it to perform reliably in your projects. To measure resistance, ensure that your black lead is connected to the COM jack and your red lead is connected to the VWMA jack. Next, select the appropriate range from the resistance measurement options for your expected resistance. In checking for continuity, you can use the lowest range of 200 ohms. Now, make sure that your circuit is powered off and carefully touch the black and red leads of your meter to the point that you'd like to measure. If your display is showing 0 to the left of the measured value, then you can switch to a lower range to obtain a better reading. Now, if your display is showing a 1, then your selected range is too low for this measurement. Switch to a higher range to display the measured value. If your range continues to display a 1 on the highest range, then the 2 points you're trying to measure are not connected, and this could be due to a failed component or a jumper being inserted into the wrong hole in the breadboard. Here are some common resistance measurements that you might make and what values to expect. So if you're measuring a jumper wire, you would look for very low resistance, less than 10 ohms. A single resistor, the resistance value should be measured. So if you're measuring a 220 ohm resistor, that should be around the measurement you're getting. If you're trying to measure resistors in series, you'll want to add the values of those resistors together, and that should be your expected value. Now for resistors in parallel, we've done this before, right? It's the inverse of all resistors in parallel would be your expected value. Okay, so that sounds confusing, I know, but if you want to learn more about this, you can refer back to previous lessons where we've talked about resistors in series versus in parallel, or you can check out these websites here, or this one website here, to learn more about measuring resistors in parallel. All right, current measurements can be used to determine how much current is flowing through a specific point in a circuit. Measuring current is different than voltage or resistance in that to measure current, you must break the circuit at the point you wish to measure and use your multimeter to complete that portion of the circuit. You'll use the current measurement range on your multimeter for this task. The amount of current you plan to measure will determine which location you'll use for that red lead connection on your multimeter. So the standard VWMA jack will only support 500 milliamps of current. If you plan to measure current values greater than 500 milliamps, then the 10 amp jack should be used for the red lead connection. Running more than 500 milliamps of current through the standard VWMA jack can actually damage the internal components of your multimeter. So here's a chart of the current measurement ranges that are available and the corresponding red lead connection that should be used. In order to measure current, you must first determine how much current you plan to measure and set the range selection and your red lead position appropriately. If you're unsure if the current you plan to measure will exceed the 500 milliamps, go ahead and start by using that 10 amp range and the 10 amp red lead jack. You can always select a lower range and move the red lead to the VWMA jack to get more accurate measurements later. If you accidentally overload that 500 milliamp rating on the VWMA jack, then your multimeter may be damaged. So always err on the side of caution if you think there's any potential you're going to exceed that 500 milliamp limit. After the proper range and the red lead position have been selected, you must power the circuit down and break the circuit at the point that you'd like to measure. Next, complete the circuit using the leads of your multimeter, making sure to keep the black lead toward ground or the negative of the battery. Reversing the leads won't damage anything, but your current reading will indicate a negative current value, which will probably be a little confusing. When the circuit is powered back on, current will flow through the multimeter and the amount of current measured will be displayed on the screen. If there are components like switches or LEDs in the circuit that might affect the circuit at your measurement point, then you can try switching those components on and off to watch how they change your current measurements in real time. And when you're done measuring the current, power the circuit down and remove your multimeter from the circuit. Make sure to complete the circuit in the location you were measuring so it will operate properly with your multimeter now removed from the circuit. Okay, before you move on to the activities for this lesson, let's take a few minutes and go over the things we discussed in the last two videos. The multimeter in your level D kit can be used to measure voltage, resistance, and current, as well as check diodes and transistors. The rotator dial on the front turns the device on and is used to select the type of range you'll be measuring. The multimeter has 2 leads, right, and 3 jacks, and the red lead can be plugged into different jacks depending on what's being measured. Voltage can be measured for most Raspberry Pi projects by selecting the 20 volt range and touching the black lead to a ground point and the red lead to the point you want to test. To measure resistance, the component must be powered off so the multimeter can run a tiny amount of current through the component. If you see references to measuring continuity, this means checking for low resistance between 2 points or making sure those 2 points are electrically connected. And finally, we can use the multimeter to measure how current is flowing through the circuit. And to do this, we must power down the Pi, break the circuit connection, and then use the leads to complete the circuit and then power the pi back up to take the measurement. All right, go ahead and move on to the activities for this lesson where you'll have a chance to practice using your multimeter. And then in the next lesson, as I promised, you will get to start building your robot.